Hello dear student, once again I welcome you in digital learning session of analog communication. So in previous lectures we have seen the uniform distribution function and exponential distribution function. So let us take some numericals problem of these distribution function one by one. So our first numerical problem is for a continuous random variable capital X, that is density function, is given by this figure. So we have to determine the statistical averages for this density function. So the first statistical average is mean. So this mean is given by m1 and its formula is integration from minus infinity to plus infinity x dot fx dx. Since our probability density function is distributed between minus 10 to plus 10, so our limit will be from minus 10 to plus 10 and x dot. Now value of fx is constant between minus 10 to 10, that is 1 by 20. So it is 1 by 20 dot dx. So this 1 by 20 is constant, bring it outside, minus 10 to 10 x dot dx. So that will be 1 by 20 x square by 2, because integration of x is x square, lower limit is minus 10, upper is 10. So when we substitute this, so this will be 0. And as we know very well that for a uniform distribution function which is distributed among minus a to plus a, its mean will always be 0. So this is the first statistical average. Second statistical average quantity is square mean. So which is given by m2. So this m2 is minus 10 to 10 x square. Now minus 10 to 10, our fx is 1 upon 20 dot dx. 1 upon 20 constant, bring it outside, integration minus 10 to 10 x square dot dx. So this is 1 upon 20. Now x square integration is x cube by 3 from minus 10 to plus 10. So this is 1 upon 20. 1 upon 3 is also constant. So when I substitute upper limit, this will be 10 to the power 3 minus lower limit, so that is minus 10 to the power 3. So this will be 1 upon 60 into, now this is 1000 minus minus minus. Now this is minus and this minus will become plus. So 1000, so this will be 2000 upon 60, and that will give you 100 by 3. So 100 by 3 will be the square mean for this density function. Third is variance, given by sigma square. So sigma square will be m2 minus m1 square. m2 is 100 by 3 minus m1 is 0, so 0 square, that is 100 by 3. And last is standard deviation. So standard deviation is square root of variance, so that is square root of 100 by 3, which is nothing but 10 by root 3. So likewise we can calculate the statistical average quantities for the given density function. So this is for the uniform distribution function. Now let us take next problem, which is related to the exponential distribution function. So our next problem is, for a continuous random variable given small fxx is equals to a e to the power minus bx for x greater than or equals to 0, then we have to find the relationship between a and b, probability of all the random variable between 1 and 5, and we have to plot the probability density function. So one by one we will see. So first is find the relationship between a and b. So since we know that in the question we have probability density function, and we know the area under probability density function must be equals to 1. So we may write integration minus infinity to plus infinity fx dot dx must be equals to 1, and this expression denotes the area under this probability density function must be equals to 1. So in our case, in this question, the given probability density function is defined for x greater than or equals to 0. So we may write integration 0 to infinity. Now our fx is this a e to the power minus bx dot dx, and that will be equals to 1. So when we perform the integration, we may get a integration of minus b e to the power minus bx, we will get e to the power minus bx upon minus b from the limit 0 to infinity, and this will equals to 1. So a, when we substitute the upper limit, we will get e to the power minus infinity, and that is nothing but 0. When we substitute lower limit, so this e to the power minus b0 will be 1, and minus minus will be plus. So this is 1 by b is equals to 1. So this will give us the relationship between a and b. That means a is equals to b for the given exponential density function. Now our second question is, we have to determine the probability of all the random variable lies between 1 and 5. So that can be written as probability of all the random variable 1 to 5 is, lower limit is 1, upper is 5, a e to the power minus bx dot dx. So this will give us, a is constant, so bring it outside, e to the power minus bx upon minus b, as we already performed here. So 1 and 5. And now we know that a is equals to b. So either we can substitute this a as b, or we can substitute this b as a. So this is a to the power minus ax upon minus a. I am substituting b as a. So this is cancel out. We will have minus e to the power minus ax for 1 to 5. So when we substitute the upper limit, we will get minus e to the power minus 5a, and minus minus plus, lower limit will be e to the power minus a. So probability of all the random variable in between 1 and 5 will be e to the power minus a minus e to the power minus 5a. Now the third is, we have to plot the probability density function. Actually we are interested to plot the probability distribution functions. So this is capital F. So we have to plot the probability distribution function for the given probability density function. So third is fx small x. We may write integration 0 to infinity a e to the power minus bx dot dx. So when we perform the integration, so for plotting I assume 0 as the lower limit or the lower range of on x-axis, and I assume small x is the large range of x, or we can say that small we replace this infinity by the term small x. So our integration will be 0 to small x a e to the power minus bx dot dx. Since the a and b are same, so this is integration 0 to x a e to the power minus ax dot dx. When we perform the integration, this is a e to the power minus ax, integration is e to the power minus ax upon minus a from 0 to x. This a will become cancelled, so we will have minus e to the power minus ax for the limit 0 to x. So this will give you, when we substitute the upper limit, minus e to the power minus ax